Good morning, boys and girls, and welcome back. Again, my name is Mr. Mortara, and I have the pleasure of presenting to you the first few days of Unit 7 on polynomial factoring, and solving polynomials. On these first few days, we're going to cover division of polynomials. Today, we're going to look at the long division of polynomials, and tomorrow we will look at or on the second day, we will look at synthetic division, which I'm sure you're going to like a lot more than long division. But here we go. In order to long divide polynomials, we are first going to start reviewing just how to long divide numbers in general. Okay, so we're going to start with this problem right here. All right, a few little vocab review stuff here. The number on the inside, well, first is our division sign, right? This little thing indicates division. The number on the inside is called the dividend. The number on the outside is called the divisor, and our answer is called the quotient, okay, of a dividing problem. All right, and so when we divide, you are going to go ahead and you are going to look at, generally, 12 into 502, probably don't know how many times that happens, so we kind of estimate. We look at 12 and we say just into 50. We kind of look at our place value. So we look at just the tens places. And 12 into 50, hopefully you know. If you didn't, okay, you could always come back and you could just look at the 1 and the 5. Okay, how many times does 1 go into 5? If you guess 5 times, because we're going to two place values here, I'd put the 5 up on top of the 0. Very important in our work that we stay organized, and even more so, not with the numbers, but with the polynomials we're going to get to. That's what I'm trying to emphasize. Some place like where we put things here. If I went 5 times 12, I would get 60, which I can see is too big, right? And we write that number underneath it right here. But 60 is too big because we're going to subtract this. So this is a good way for us just to kind of estimate and begin. I know 5 was too big, so now I'm going to try 4. 4 times 12 is 48. Again, you put that number on top of where we went to. Then you're going to multiply this times the number in front. 4 times 12 is 48. And then we subtract this. 50 minus 48 is 2. We know we're good, again, when that number is smaller than the one that's on top. So like 60 was too big. And when this number that I get when I subtract is smaller than my divisor. Okay? Once we get that all looks good now. We can go ahead and we can bring down our next number. We bring that one straight down, if you remember. And we go 12 now into 22. We play the same game all over again. 12 goes into 22 one time. 1 times 12 is 12. I subtract, I have 10. Again, that is less than that one there. So that is good to go. And now, it's just how do we write this answer? Back in the old days, we would say, hey, 41 remainder 10. Remember those days? Those were good, huh? If you don't like that, as we got a little more sophisticated, we said you could add zeros, right? A decimal and some zeros. And you could just keep bringing down stuff, until you don't have anything left over, or until you see a pattern emerge. That seems like a lot of work right now, so I don't want to do that, but that was another option we did back in the day in elementary school. Or the other way that I kind of prefer is we can say that this is 41, and I can write this as a mixed number. And I can take my remainder and put it over my divisor. So 41 and 10/12. Or we can say this is 41. If I reduce that, and I get 41 and 5/6. And this is now, like with polynomials, that's the way we're normally going to write our answers. All right, one more problem here. Just a different setup on this, and I just want to talk about the setup here, and then I'll let you try this on your own. But when you see a problem written like this, the dividend, or the number that goes inside, always comes first. The divisor, or the number that comes on the outside, always goes second. All right? So if I were to set this up like our last problem, if I were to do this, 83, the second number always goes on the outside, and 4, 5, 4, 3 always goes on the inside. All right? Now, use your estimation skills, and I want you to try to do this one on your own. Go ahead and pause the video, take a few seconds, and see what you come up with, and you can check your work against mine. Okay, hopefully you got 54 and 61/83. Okay, 54, 61, 83rds would be the correct answer. Again, starting this, 83 does not go into 4 or 45. It goes into 454. So those red underlines is kind of where I start. And again, I just looked at the 8 and the 45 to estimate, how many times does 8 go into 45, to estimate my first number there. That goes 5 times. 5 times 8 is 40. And then I multiplied 5 times 83 and got 415. Subtracted. Brought down my 3. 4 times 83 is 332. Subtracted. And again, what's left at the very end is my remainder when I have nothing left over. And so that remainder, again, I can put on top of my fraction and write this as a mixed number. 54, 61 over 83. All right, now we do the same thing with polynomials. Okay, if we look below on our notes now here, moving around in our notes, polynomial long division. If we look to the side here, this is, okay, what it's going to look like with polynomials. We still have our dividend and our divisor, okay? We are going to use a lot of the same setup you can see here. This one's all kind of worked out. I'll kind of go through the steps here in a second and some of the problems below. But you can see we're going to do the same thing. We're going to use the front things to estimate what we are going to need. I'm going to multiply the front, or the first term times the front, and then I subtract this stuff right here. And we keep going down. I bring down things. I bring down stuff. All right, until we get to a remainder. And in this case, this had a remainder of 0, so it worked out nice and happy. All right, that won't always be the case, especially the ones we're working with to begin with. But down the road, when we start to factor, it should work out nice and happy for us. All right, so let's put this into action. All right, so coming to our problems. I don't know why mine are kind of weird here. This is for the next problem. Let's just ignore it. We're going to do just number 3 here. I can get to show up. All right, we want to divide x cubed minus 6x squared plus 9 divided by x minus 4. So the first thing we have to do is we have to set it up. Okay, so important things about when you set it up. The divisor is the second thing. That goes on the outside. The dividend is on the inside. Kind of like when we did synthetic substitution, it's very important when you are missing a term. X cubed, x squared. This did not have an x term. When I'm missing a term, I have to put a 0x and then plus 9. Okay? That is the way I want it to look. But make sure that you have a thing for everything. If it's on the inside, you're missing a term, put a 0x, 0x squared, 0x cubed, whatever you're missing. Same thing, if it's missing something on the outside, put a 0x, 0x squared, whatever. If you're missing something in the middle, you need to put a 0. All right, now to go and divide. I'm going to, again, just look at the front stuff, just like we did with the numbers to kind of help me estimate. And I'm going to say, hey, what would I have to multiply x by to give me x cubed? I think it's way easier if you ask the question in that direction. What would I have to multiply x by to give me x cubed? It's the same as saying what would be x cubed minus x, or x cubed divided by x. But as things get more complicated, I think it's harder to think of things that way. So what would I have to multiply this by to give me that? Well, I'd have to multiply by x squared. And again, because we are 2 terms deep, I'm always going to stack like terms. There's a great way to keep you organized and make sure you don't mess up. X squareds should be on top of x squareds. Okay? So x squared times x gives me x cubed. That's what I was looking for. And then I need to place it on top of its like term. Now, like we did the numbers, I'm going to multiply this times everything in front. So x squared times x is x cubed. X squared times negative 4 is minus 4x squared. And when I come down to do this, again, I should have like terms stacked. That's a way to kind of indicate that I'm on the right path, that I'm doing the right thing. And now I need to subtract this. And when I subtract this, I don't just want to put a minus sign like that out in front, because then I'll forget to subtract this thing back here. So the best thing to do, like when we subtracted before, is distribute that negative. Okay, so when I subtract, I just go and change signs on everything so that I know I'm going to be okay. Now x cubed minus x cubed is 0, and that's what should happen. Those should kill each other off. Negative 6x squared plus 4x squared is negative 2x squared. And now I want to bring down the next term, plus 0x. And we're going to play this game all over again. X times what gives me negative 2x squared? Oh, I know. X times negative 2x is negative 2x squared. And again, always stacking like terms. If I multiply this times the front now, negative 2x times x is negative 2x squared. Negative 2x times negative 4 is positive 8x. And now again, I want to subtract this. So to subtract this, I'm going to distribute my negative. Go and change the signs on everything. So that becomes a plus, and this becomes a minus. Those cancel out as they should, and we're left with negative 8x. And then again, I need to bring down plus 9. And now my last time of doing this, hey, x times what gives me negative 8x? Minus 8, again, stacking like terms. Negative 8 times 8x, or times x minus 4 is negative 8x plus 32. Going to go and distribute my negative plus minus. Those die off, and I get 9 minus 32 is negative 23. And now there's nothing else to bring down, right? We brought everything down. So I'm at the end. This is my remainder. So what we're going to do, just like we did the numbers, is x squared minus 2x minus 8 plus whatever your remainder is, negative 23, over what you divided by, x minus 4. And that, boys and girls, is how you divide polynomials. All right, let's do this again with number 4. First, let's start with the setup. Okay, x squared plus 2x plus 4 goes on the outside. 4x to the fourth. Again, we're missing an x cubed term, so I had to put 0x cubed plus 5x squared minus 9x plus 18. If you don't do this plus 0x cubed, you will find out real fast that your like terms are not matching up, and that way you'll know you'll have a problem, okay? If you're ever missing a term, make sure you put in a 0x cubed. All right, now we're going to start with the fronts. What do I have to multiply x squared by to give me 4x to the fourth? Hopefully you said 4x squared. And again, because this is 3 terms deep now, I have to put my answer 3 terms deep. Again, lining up like terms. These are little ways to check to make sure these are going to be a lot of work, but to organize your work to make sure that you're doing it properly. Now I need to multiply by the front and subtract. When I multiplied, I got 4x to the fourth plus 8x cubed plus 16x squared, and now I needed to distribute my negative to subtract. When you subtract it, you should get negative 8x cubed minus 11x squared. And now I'm going to bring down the negative 9x and play this game all over again. What do we have to multiply x squared by to give me negative 8x cubed? Hopefully you said negative 8x. Now let's multiply and subtract. When you multiplied and subtracted, hopefully you ended up with 5x squared plus 23x plus 18. Okay, you can pause the video if you need to kind of double check your work or copy down my work. Trying to keep this short for you boys and girls. And now I'm going to do this one last time with the 2 fronts right here with the 5x squared and the x squared. What do I have to multiply this by? Hopefully you said 5. When I multiply by 5, I get 5x squared plus 10x plus 20. Distribute the negative again. And we end up with 13x minus 2. And now there's nothing left to bring down, so that is our remainder, right? So now I'm going to write our answer. The quotient is 4x squared minus 8x plus 5, always plus your remainder, plus 13x minus 2, all over what you divided by, x squared plus 2x plus 4. And that would be our answer. Okay? Easy peasy lemon squeezy. All right, last one I'm just going to set up for you, and then I'll show you the work really fast because I want to keep this under 15 minutes. Okay, I don't know if your notes were messed up like mine were, but the problem is 3x to the fourth minus 5x cubed plus 4x minus 6 divided by x squared minus 5. So when you set it up, it should look like this. Some important details would be the 0x, because this did not have an x term, and the 0x squared here, because it did not have an x squared term. All right, now go ahead and try to divide this on your own, and you can check your answer. Okay, you can pause it here and check your work if you need to, but you should have ended up with 3x squared minus 5x plus 15 plus negative 21x plus 219 all over x squared minus 5. if you, again, try to keep things lined, but I think it makes these problems easier. Ask questions if you have them. See you, boys and girls.